بسم الله الرحمن الرحيم. أعزائي طلبة المرحلة الثالثة في قسم الفيزياء كلية العلوم الجامعة المستنصرية. السلام عليكم ورحمة الله وبركاته. In this video I'm going to talk about voltage filtration. Okay, we have already known that the output of rectifier has two components, AC and DC. Such output is referred to as a pulsating. The AC component is undesirable because many of applications are currently requiring a pure DC voltage. So, the AC component has to be minimized as low as possible. For doing that, the so-called voltage filter is used. Usually, three types of voltage filter are used. The first one is called RC filter. As shown in this figure, it is composed of a capacitor and a resistor connected in parallel with the output of the rectifier. That means the output of the rectifier is the input for the circuit of the RC circuit. The impedance X sub C is represented by this equation, which is equal to the reciprocal of 2 pi times Fc. Now we study the operation of an RC filter. Please look at these two figures. In the electronic circuit, the load is 5 kilo ohm and the capacitance is 500 microfarad. The input and the output waveforms are shown in the right-hand figure. The blue one is the input and the green one is the output. The output of rectifier with a peak of 4.4 volt is applied to the filter. So, during the first quarter of the input, the capacitor will charge to 4.4. But during the second quarter, the diode becomes in reverse bias because the capacitor voltage is higher than the input voltage. For example, if the capacitance voltage is 4.4 voltage while the input voltage is 4 volt, that means the diode is in reverse bias. Thus, the capacitor will discharge through the load until reach 3.2 volts. At this voltage, the input voltage becomes higher than the capacitor voltage, so it will charge again. This is clear in the third quarter, and then it discharges. The process is repeated, and finally we get the green waveform with a ripple voltage of 1.2 volts. This is easily calculated. 4.4 volt minus 3.2 volt. This is equal to 1.2 volt. The significant question here is, what happens if the capacitance increases? The answer can be obtained by looking at these two figures, which compare between the ripple voltage corresponding to different values of capacitance, 1000 microfarad and 1500 microfarad. Apparently, when the capacitance increases, the ripple decreases. That means the right-hand figure is better than the left-hand figure. أعزائي الطلبة، اعتدنا في المحاضرات السابقة على إعطاء سؤال open question، والطالب الذي يتمكن من الإجابة عليه يمكن أن يحصل على درجة. هنا سؤالان أتمنى الإجابة عليهما. The second type of voltage filter is called LC filter. As shown in this figure, it is a series circuit of a coil and a capacitor connected to the output of the rectifier. The important thing here, one can use a number of identical sections until getting the smoother waveform. The induction can be calculated using this equation. X sub L is equal to 2 pi FL. In this circuit we use induction of 100 millihenry, capacitance of 500 microfarad and load of 5 kilo ohm. Operation of an LC filter. The principle of this circuit can be understood on the fact that the capacitor is approximately closed switch to an AC component, whereas it is an opened switch to a DC component. Additionally, the inductor behaves in opposite method. That means it prevents the AC component and allows the DC component to pass through it. However, as shown in this figure, this output is not so much different from the RC filter. This figure shows the output that correspond to different values of capacitance, 1000 microfarad and 1500 microfarad, with limited values of inductors and load. Again, when the capacitance is increased, the ripple voltage will decrease as shown in these figures. The third type of voltage filter is called bisection filter. As seen in the electronic circuit here, it is similar to bi-symbol. It has two capacitors connected to a coil. The output waveforms for two different values of capacitance, 1000 microfarad and 1500 microfarad, are shown below. The ripple voltage is clearly less than the previously studied due to adding an extra capacitance. Again, when the capacitor increases, the ripple voltage decreases as well. In this example, an LC filter is connected to full wave rectifier. The chuck has an impedance of 100 ohm and the applied voltage is 25 volt. The question about the output DC voltage on the load, which is RL, 1 kilo ohm. The solution is very simple. Here, this is voltage divider between XL and RL, and you can calculate VDC from this equation. VDCN times RL over RL plus XL. XL 100 ohm and RL 1 kilo ohm. And the VDC, because this is full wave rectifier, can be calculated by 2 V sub B over by. The VDC then is equal to 14.46 volts.